Yeah, is my screen visible, children?
Yes, ma'am.
Yes,
Okay.
ma'am. Ma'am, I have a doubt.
All right. Yeah, just a second. I'll just do it again. Now, tell me what is the multiplicative inverse of 7 by 5?
Ma'am, 5 by 7. 5 by 7.
5 by 7. What's the multiplicative inverse of 5 by 7?
7 by 5.
7 by 5. What's the product of 7 by 5 and 5 by 7?
Ma'am, 1.
1. What's the product of 5 by 7 and 7 by 5?
1.
That means A by B into B by A is 1, right? And what is this? This is B by A. See, this is B by A. A by B is 7 by 5. And B by A is 5 by 7. And what is this? B by A? Sorry, 5 by 7, B by A. 7 by 5 is A by B. So A by B into B by A is the same as B by A into A by B is equal to 1. That's what you see here in the reason statement. Yes or no? The reason statement says that the product of a rational number and its multiplicative inverse is 1. And the assertion statement, the multiplicative inverse of a rational number A by B is B by A. This is true. This is also true. And the reason statement talks about the assertion statement. Or the reason statement is related to the assertion statement. Both are about the multiplicative inverse. So the correct option is A and R are true, and R is the correct explanation for A. Now, when you take the rational number 0, 0 is 0 by 1. 0 means 0 by 1, and its reciprocal is 1 by 0. 1 by 0 is not defined. So 0 does not have a reciprocal. The rational number 0 does not have a reciprocal. 0 is a rational number. What is the reciprocal of 0? 0 is 0 by 1. So what's the reciprocal of 0 by 1? 1 by 0. This is not defined. So 0 is a rational number which does not have a reciprocal or a multiplicative inverse. So that's what here in the statement, it's about a non-zero rational number, not 0. A rational number, but not 0. So then this is true. Okay. Akshita, what's your question? Quick.
Ma'am, for the first one, they are asking about the multiplicative inverse only, right? So it's A by B is equal to B by A, but the reason it's like a commutative property, right?
No, it's no. The reason is A by B into B by A. The product is 1 only, right? The product of a rational number, and its multiplicative inverse is 1. See here, A by B. What is A by B here? Rational number. What is B by A? Multiplicative inverse. The same as here. Rational number, multiplicative inverse.
So both are not related, ma'am.
No, they are related. The product of a rational number and its multiplicative inverse is 1. It's just put together. See here. If you take 7 by 5 as a rational number, what is its multiplicative inverse? 5 by 7. Right?
Yes, ma'am.
What's the product? 1.
Okay, ma'am. Now I understand.
The other way around also. This is the multiplicative inverse, this is the rational number. That product is also 1. See here A by B is a rational number, B by A is the multiplicative inverse, and rational number into multiplicative inverse is 1, is what is given here.
Okay, ma'am. Now I understand.
So the correct option is A. Both A and R are true, and R is the correct explanation for A. A rational number between 2 by 3 and 3 by 4 is 17 by 4. 17 by 24, sorry. Okay, so let's bring 2 by 3 to the denominator 24. So it will be 16 by 24. And 3 by 4 to denominator 24 will be 18 by 24. So clearly 17 by 24 is a rational number between 2 by 3 and 3 by 4. Write 2 by 3 with denominator 24. So you'll have to multiply and divide by 8. Write 3 by 4 also with denominator 24. So multiply and divide by 6. So we have 16 by 24 and 18 by 24. And 17 by 24 is a rational number between 2 by 3 and 3 by 4 is true. This is true. The reason statement says that between any two rational numbers a and b, there will be another rational number half into a plus b. True. That's how you find a rational number, or that's how we insert a rational number between two rationals. Don't we add the two numbers? We add the two numbers and then divide by 2. We add the two numbers and divide by 2. That's nothing but a plus b. Division becomes multiplication. And the reciprocal of 2 is 1 by 2. So a plus b into 1 by 2 or 1 by 2 into a plus b. Both are the same. I'll write this again for you. To insert a rational number between two rational numbers, you'll have to add the two rational numbers and divide by 2. So that means add the two rational numbers, division becomes multiplication, and the reciprocal of 2, which is 2 by 1, is 1 by 2. So this is nothing but half into a plus b. A plus b into half, half into a plus b. So this is true. And clearly the reason statement is talking about the assertion statement. In the assertion statement, a rational number between 2 by 3 and 3 by 4 is 17 by 24. And you can see the reason statement is about the assertion statement. Between two rational numbers, a and b, there will be another rational number, which is half of a plus b. Is true. And the reason is talking about the assertion. So here also both a and r are true, and r is the correct explanation for a. I'll share these images because these will take time for you to write now. We'll just discuss. I'll share these images on WhatsApp. You can complete it before the next class. Is this understood, all of you?
Ma'am, me and Anvin wrote now itself, ma'am. Yes, ma'am.
Okay, fine.
Yes,
Any questions?
No, ma'am. No, ma'am. No, ma'am.
No, ma'am.
All right, next one. Root 2 by 3 is a rational number. True or false? You have to tell me. Root 2 by 3 is a rational number.
Ma'am, no, ma'am. It's false.
No, ma'am. False.
Why? P by Q, no. Root 2 by 3, P by Q.
Oh, yeah, integer by integer.
Akshita?
Ma'am.
Yeah, tell me. P by Q form, no? Is it a rational number or not?
Rational number, ma'am. But how, ma'am? If you're finding its root now, it will go in. It's a irrational number, right? It will keep on going, right?
So you feel it is not a rational number, is it?
Yes, ma'am.
Okay. What about the boys? And Harini?
Ma'am, we think it's a rational number. Ma'am, it's a rational number.
Okay. Okay. So Akshita's answer is right, but I'll tell you how it is to be understood. Root 2 by 3 is not a rational number because root 2 is not an integer. P by Q, integer by integer, not something by something. Integer by integer. Is root 2 an integer? What are integers? The collection of all natural numbers. The collection of all natural numbers, their negatives, including 0, form the collection of integers. These are integers. Where do you have root 2 among integers? Root 2 is a real number. but it's not an integer. It's an irrational number. You know that real numbers are rational numbers and irrational numbers put together. Rational numbers and irrational numbers put together are called real numbers. So root 2 is a real number. Root 2 is not an integer. Because what is the definition of an integer? The collection of all natural numbers, their negatives, including 0, form the collection of integers. So we don't have root 2 in this collection. So something by something is not a rational number. Integer by integer is a rational number. So here root 2 is not an integer, and hence root 2 by 3 is not a rational number. So the assertion statement is false because this one is not an integer. That's not an integer. This is false. Number which is of the form p by q where p belongs to z. I have given you this. Integers are represented or denoted by the letter Z, and this symbol stands for belongs to. Belongs to. P belongs to Z. See here. Listen. P, the numerator P belongs to Z. That means the numerator P is an integer. Z denotes integers. N denotes natural numbers. W denotes whole numbers. I or Z denotes integers. Q, rational numbers. Natural numbers N, whole numbers W, integers I or Z, rational numbers. Rational number is P by Q, right? So division it is P divided by Q. So division means quotient. So Q. So the numerator P belongs to integers. The denominator Q also belongs to integers. And Q not equal to 0 is called a rational number. Perfect. Perfect. See your number which is of the form P by Q where P belongs to integers, Q belongs to integers. Yeah, P is an integer, Q is an integer. Sorry, Q is an integer. And the denominator Q is not 0, is a rational number. Perfect. Complete definition of a rational number. This is the complete definition or explanation for a rational number. So this is true. This is false. So assertion is false, but reason is true. Assertion is false. Reason is true. Got it, children?
Yes, ma'am.
Okay. Yeah, read and answer this one. Yeah, ready with the answer?
Yes, ma'am.
No. Yes.
Okay. Is the assertion statement true?
Ma'am, false, ma'am.
Okay, assertion is false, is it?
Ma'am. Yes, ma'am.
False. Ma'am, the answer is the option D, ma'am.
Okay, Akshita says option D is the correct option. All right, let's see. Okay, let me work. So it's given A5. We'll work A plus 1 by A when A is 5. So A plus 1, 5 plus 1, 6, 6 by 5. The additive inverse of 6 by 5 is minus 6 by 5. True. Assertion is true. The additive inverse of A plus 1 by A. What is the value of A? 5. 5 plus 1, 6. 6 by 5. What's the additive inverse of 6 by 5? Minus 6 by 5.
Minus 6 by 5.
Now you're repeating with me. You said it's false.
We didn't say.
Ma'am, so option C is the correct answer, ma'am.
Somebody among the boys said it's false, the assertion statement. I don't know if all of you said that, but one of you voiced out that. The reason is the additive inverse of any non-zero rational number is its reciprocal. Are the terms synonymous? Are the terms additive inverse and reciprocal synonymous? Do they mean the same?
No, ma'am.
What is a synonym? What's the other term for additive
Ma'am,
inverse?
reciprocal means we are changing the number.
I want the other term. I don't want the explanation. I want the other term. What is the other term for additive inverse? What's the other term? Did I get the answer from you? What's the other term for additive inverse?
Inverse.
I'll forget maths now.
Ma'am, the multiplication, the actual statement is the multiplicative inverse of any reciprocal of. Yeah.
See, children, my question is, what is the other term or what is synonymous?
Rule of 0.
My God. I'm sorry to give.
Ma'am, if we divide a rational number and the second number,
relax, children. Children, take my question clearly. Relax. What is that term which means the same as additive inverse?
Negative of a number.
That's what my question was, that simple. The additive inverse of any non-zero rational number is its negative. Additive inverse, negative. What is the other term for reciprocal of a rational number? Additive inverse means negative of a rational number. Then what is reciprocal? Multiplicative inverse, right? So is the recent statement true or false? Is the recent statement true or false?
Ma'am, false.
False. Yeah, false. So which is the correct option?
C.
C. Option C is the correct option. Option C is the correct option. Because this is true, this is false. The additive inverse of a non-zero rational number is its reciprocal. No. Additive inverse, reciprocal, they don't mean the same. Additive inverse is negative. Reciprocal is multiplicative inverse. So the reason statement is false. The assertion statement is true because when A is 5, it is 5 plus 1, 6. 5 plus 1, 6. 6 by 5. And its additive inverse is minus 6 by 5. Assertion true, reason false. So option C is the correct option. If x is equal to minus 2 by 7, then the absolute value of minus x is minus 2 by 7. See, the absolute value of any number is always positive. Listen to this carefully. The absolute value of minus 3 by 7 is 3 by 7. The absolute value of 3 by 7 is 3 by 7. Absolute value of a rational number is the numerical value regardless of the sign. Don't take the sign into consideration. Just see the numerical value. Do not take the sign into consideration. Just see the numerical value, minus 2 by 7. The absolute value of minus 2 by 7 is 2 by 7. So whether it is negative or positive, the absolute value is always positive. Whether the given rational number is negative or positive, the absolute value of that rational number is always positive. But when you have to write the additive inverse, if it's plus, if it's positive, additive inverse is negative. If it's negative, the additive inverse is positive. Don't get confused with additive inverse and absolute value. Not to get confused with additive, not to get confused with additive inverse. Additive inverse, you know. Now what you know is additive inverse. What is new is absolute value. Absolute value. And this symbol stands for absolute value. Absolute value of minus 2 by 7. The absolute value of minus 2 by 7 is 2 by 7. The absolute value of 2 by 7 is also 2 by 7. That's it. This is very simple. There cannot be any doubt on this one. The absolute value of any rational number, whether it is positive or negative, is always positive. That's it. Discussion closed. Now, the assertion statement says the absolute value of minus x. See here, minus x. What is x? Minus 2 by 7. See here, absolute value. See, I'm writing it again. Absolute value of minus x. So minus x. What is x? Minus 2 by 7. So let's simplify this. There's nothing but absolute value of minus into minus plus. Plus 2 by 7. Absolute value of anything, whether positive, negative, is always positive, is 2 by 7. See, basically, if you have this symbol, absolute value, the answer has to be positive. It cannot be negative. Absolute value of whatever is always positive. But so you don't have to work anything here. Just look at this. Absolute value of minus x, they're saying is negative. Wrong, that's all. Finished. You don't have to work anything. I'll show you again. Absolute value. So absolute value answer is always positive. Absolute value of minus x, whatever, should be positive. But what is given here? Negative. So false. The reason statement is the absolute value of any rational number is always non-negative. Is always non-negative. True. The absolute value of any rational number, it's not negative. It's non-negative. Non-negative means 0 or positive. The meaning of the term non-negative is 0 or positive. You can just make a note of that. I'll share this with the answers. So with the steps. So don't worry. The meaning of the term non-negative is 0 and positive. So here the assertion statement is false. The reason is true because the absolute value is non-negative. That means it can be 0 or positive. Yes, because the absolute value of 0 is 0. The absolute value of 0 is 0. So it can be 0 or it's always positive. It's never negative. Absolute value is never negative. So this is true. So the correct option is option D. Assertion is false, but reason is true. All right. Harini?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
The boys and Akshita?
Yes, ma'am.
Very good. Srijit, I just noticed you. Good evening.
Good evening, ma'am.
Are you there from the beginning of the session today?
Yes, ma'am. I'm there from the beginning of the section.
Oh, okay. I don't know how I just didn't notice you. I'm sorry. Fine so far, Srijit. Any questions?
No, ma'am. No issues.
Okay. Okay. Now, before we do this matrix matching, we'll just recall one thing, children. I have told you how to identify if a rational number will have a terminating decimal expansion or a non-terminating repeating decimal expansion. See, let's just recall that part. Rational numbers, if a number is a rational number, then it can have two types of decimal expansions. Either it will be a terminating decimal or a non-terminating but repeating decimal. Rational number is a number of the form P by Q. P by Q means division. A rational number is a number of the form P by Q. P divided by Q, meaning division. So when you divide case 1, the division may come to an end with a 0 remainder. And in that case, the quotient will be a terminating decimal. Case 2, the division does not come to an end. It goes on and on forever. And the quotient obtained will be a non-terminating repeating decimal only. The quotient will not be a non-terminating, non-repeating decimal. It will not be. The quotient will be a non-terminating repeating decimal. So rational numbers are of two types. Or rational numbers can have only these two types of decimal expansions, terminating or non-terminating repeating. I repeat, rational number is of the form P by Q. P by Q meaning division. So when you divide P by Q, case 1, the division may come to an end with a 0 remainder. You do the division process and you're happy, you get 0. 25 minus 25, 0. The division comes to an end. And when you see the quotient, you will see a terminating decimal. Terminating decimal. Case 2, the division may not come to an end with a 0 remainder. Your hands are aching. The division is going on and on. The division does not come to an end with a 0 remainder. It's going on and on. When you see the quotient will be a non-terminating but repeating decimal. So these are the two types of decimal expansions a rational number can have. Now consider this rational number 2 by 15. Is 2 by 15 in the simplest form, children? Can you simplify 2 by 15? Or is it in the simplest form?
It's in the simplest form, ma'am. Yes, ma'am.
Yeah, it is already in the simplest form. Now look at the denominator. Look at the denominator 15. What is 15? 3 into 5, correct? Now, if the denominator has a prime factor other than 2 or 5, then that P by Q will have a non-terminating repeating decimal expansion. Put the rational number in the simplest form. Once the rational number is put in the simplest form, look at the denominator. Find the prime factorization of the denominator. If the factorization has primes other than 2 or 5, there can be 2s and 5s. How many ever 2s, how many ever 5s? But if there is a factor, a prime factor other than 2 or 5, then that P by Q will have a non-terminating repeating decimal expansion. Now consider this example, 2 by say 10 or 2 by 20. One second. So like 7 by 20. Is it in the simplest form, 7 by 20?
Yes, ma'am.
Yeah. So factorization, prime factorization of the denominator, 2 into 2 into 5. Correct?
Yes, ma'am.
What are the factors? What are the primes in the factorization of 20? Only 2 and 5. It's okay. 2 2s, 1 5. That's fine. Only 2 and 5 you see. You don't see any other prime factor other than 2 or 5. Then 7 by 20 has a terminating decimal expansion. When you divide 7 by 20, when you divide 7 by 20, the division will come to an end with a 0 remainder and the quotient will be a terminating decimal. What is the terminating decimal? That we cannot say. That you have to divide. Or there is another procedure also. But what you can say is, by looking at the fraction, you can comment if it will have a terminating decimal or a non-terminating repeating decimal expansion. I'll just repeat that. 7 by 20 is a P by Q in its simplest form. If it is not in the simplest form, you have to reduce it and put it in a simplest form. That is the first step. Next step, look at the denominator and find the prime factorization of the denominator. Now, if the factorization of the denominator has primes made up of only 2s and 5s, only 2s or 5s, then that P by Q will have a terminating decimal expansion. Like in 7 by 20, it's in the simplest form, 20. These are the prime factors, only 2 and 5 we see. So 7 by 20 has a terminating decimal expansion. That is, the division will come to an end with a 0 remainder and the quotient will be a terminating decimal. But when you consider the rational number 2 by 15, which is in the simplest form, denominator 15, prime factorization 3 into 5, 3, 5 is good, 3 is other than 2 or 5. So 2 by 15, when you divide 2 by 15, the division will go on and on. It will not come to an end. And the quotient will be a non-terminating repeating decimal. So when you look at the fraction, you can say if that P by Q will have a terminating decimal or a non-terminating repeating decimal. And the other type of decimal expansion is non-terminating, non-repeating decimal, which is an irrational number, which does not have a P by Q form. The third decimal expansion is non-terminating, non-repeating, which does not have, which is not, which does not have a P by Q form, and which are called irrational numbers. Now, terminating decimal, you can choose more than one option. See, when it is a regular match the following, you just have to do something like this, right? That's it. For one question, there's only one answer if it is match the following. In matrix matching, you can match more than one answer to the question, and also You can, more than one meaning, you can use the same thing for, see, like for terminating decimal, for this, for everything, you can have option A also. That's fine. You can use one answer more than once. Now let's start. Let's find which of A, B, C, and D are terminating decimals. 4 by 5. Is it in the simplest form? 4 by 5?
Yes, ma'am.
Now
Yes,
look at the
ma'am.
denominator. Denominator is 5. So which is already a prime number. So the prime factor of the denominator is 5, which means its prime factor is 5. So what do you say about 4 by 5? It'll have a terminating decimal expansion.
Terminating. Yes.
Correct. Then minus 2 by 7. So it's already in the simplest form.
Yes, ma'am.
It's already in the simplest form. The denominator is 7. It's not 2 or 5. It's 7. So
Yes.
it will not have a terminating decimal.
Yes, ma'am.
1 by 3. Simplest form. 3. It's 3. It's 2. It's other than 2 or 5. So it will not have a terminating decimal expansion. 7 by 15. It's in the simplest form. 15 is 3 into 5. 3. Other than 2 or 5. So 7 by 15 also will not have a terminating decimal expansion.
Yes, ma'am.
So the only option for terminating decimal is A. 6, only A. You should not match here. You should circle like this. Now come to B. Non-terminating decimal. So since
B, D, C, D.
B, C, and D. Correct. B, C, and D. Next. Positive rational number.
A, C, D.
Negative
B,
rational
B.
number.
B. Yes, B. Last one, B.
This is matrix matching. So you can, so for the question in the first column, you can use more than one option in the second column, and you can also repeat using them. Okay. Yeah. Tell me the steps here.
Ma'am, let the other number be X.
Okay.
X plus minus 11 by 5 is equal to minus 4.
Okay. So one number plus other number
The number
is equal to minus 4. So one of them is minus 7 by 5. So let the other one be X is equal to minus 4.
Minus 4.
Yeah, then
Minus 4, X is equal to X is equal to minus 4 plus 11 by 5. Plus 11 by 5. Plus
what's the LCM?
5. Minus 20. Minus 20 plus 11
Plus 11.
equal to minus 9 by 5.
Therefore, the other number.
Other number is equal to minus 9 by 5. So minus 20.
Minus 9 by 5.
Yeah, from here you'll have to start writing. Take down quickly.
Done, ma'am. Ma'am, no need to write matrix matching.
I'll share those assertion reasoning and matrix matching. I'll share the images with you on WhatsApp.
Ma'am, assertion I completed, ma'am. I didn't complete my matrix matching alone. Yes, ma'am.
Okay. Anyways, I'll be sharing all the images. You can complete it later.
Yeah, ma'am.
Okay. Completed, all of you?
No, ma'am. Yes, ma'am. No, ma'am.
Okay. Yeah, it's time, children. Done?
Done, ma'am.
Yeah.
Ma'am, 1 minute show the previous.
Yeah.
Yeah, done, ma'am.
Okay. Yeah, try this one. Use both the methods, equivalent fractions and mean method. So method 1, Harini, tell me the answer.
Ma'am, doing, ma'am.
No, I have completed, no? Look at the screen and tell me.
Ma'am, it's minus.
No, I've asked Harini. 1 minute, she'll answer.
Ma'am, I'm only answering it.
Oh, sorry, darling. Yeah, I heard the boy's voice also. Okay, yeah, tell me.
Minus 2/6 and 3/6, ma'am.
No. See, -2/6. No. -2/6, 3/6. They are the. 1 minute, I'll tell you. 1/3 minus 1/3 is also equal to -2/6. 1/2 is also equal to 3/6. Now you'll have to write numbers between them.
Yes. Ma'am,
Think
it's
of them.
minus 2/5, ma'am. 5.
No. Now, See, like don't, the denominator is 6, right? Don't disturb the denominator. Between -2 and 3, what are the numbers between -2 and 3?
2 by 3.
On a number line, you have -2 here, you have 3 here. Tell me the integers between -2 and 3.
Minus 1, 0, 1, 2.
Yeah.
3.
So now, yeah. So this is -2 by 6, 3 by 6. So what are the here?
Minus 1 by 6, ma'am.
Then?
1 by 6, ma'am.
Okay.
3 by 6.
-1 by 6. You can also say 0 by 6 or 0. Then you said 1 by 6 and then? You can also say 2 by 6.
Yes, ma'am.
But since it's only 2, what do you want to say? -1 by 6 and?
Minus 1 by 6, ma'am.
Okay.
Yes.
Yeah, write down all of you.
Ma'am, done, ma'am, already. We are doing mean method. We are doing mean method. Ma'am, we finished, ma'am.
Okay. So the other method is the mean method. Akshita, tell me, how do you work it using the mean method?
No, mom, I have some notes, so I didn't work with that, mom.
Okay, see here. One rational number between -1 by 3 and 1 by 2. -1 by 3 and 1 by 2 is equal to, add the two numbers and divide by 2. Okay? Yes or no, Akshita?
Mom?
Add the two numbers and divide by 2. What's the LCM of 3 and 2?
6.
So what is the numerator?
-1 plus 1, mom.
Into 2 into 2 into 3 into 3 -2
2 plus
-3. 3. 3. Oh, yes, 3, ma'am. 3.
and what will happen to division? Okay, see, if you don't, you can also do this directly. Half into, see, you can do this also, half into the sum of the two numbers. Half into the sum of the two numbers. Into -2 plus 3 is 1, 1 by 6.
1 by 6.
So 1 by 12, correct?
Correct.
You need not get the same answer you've got here. Because there are infinitely many rational numbers lying between two rationals. There are infinitely many rationals lying between two rationals. So you don't have to get exactly these two numbers. You can get any answer other than those two. So now we have inserted one number. Now, one rational number between, you can take minus 1 by 3 and 1 by 12 is equal to half of, add the two numbers. And the LCM, so it will be into 4 into 4. Here it's into 1. So 1 by 12 and 5 by 24 are two rationals between minus 1 by 3 and 1 by 2.
Ma'am, we forgot to put minus.
Ma'am, yes, ma'am. Negative sign you didn't put, ma'am.
Thank you, and I'm sorry.
Ma'am, that's why I got minus 1 by 8. So after simplifying.
Sorry. Yes, I've gone wrong.
Ma'am, minus 3 by 24. And then after simplifying, we will get minus 1 by 8.
Akshita, what's your doubt with this method? Please ask me. Done, children?
Yes, ma'am.
Yeah. So 25 by 8 divided by, we'll just take it as x, okay? X is equal to minus 10. What will be the next step?
25 by 8 into 1 by x.
Into 1 by x. Division
Is
becomes
equal to
multiplication.
minus 10.
Reciprocal of x is 1 by x is equal to minus 10.
Minus 10. 25 by 8 to the other side. Yes, ma'am. So it becomes negative minus 10.
10 minus 25 by 8.
No. It won't become negative. It's in multiplication. It will go for division.
Division. Minus 1 by x is equal to.
1 second, children. 1 second. Let me say that. 1 by x is equal to minus 10. 25 by 8 and 1 by x. They're in multiplication. The operation is multiplication. So 25 by 8 will go for division to the other side. Divided by 25 by 8. 1 by x is equal to minus 10. Here. The first and second step, I'm sure you should not have any doubt, because in the first step, the dash is replaced with x. That's all. In the second step, division becomes multiplication, and the reciprocal of x is 1 by x. Now we'll have to transpose. We'll have to find the value of x. See, right? 1 by x is equal to minus 10. 1 by x is equal to minus 10. Now you have to take 25 by 8 to the other side. It's in multiplication. 25 by 8 and 1 by x, they are in multiplication. So 25 by 8 will come for division to the other side. Opposite operation. Division.
Ma'am, after that into 88 by 25. Ma'am, minus 8 minus by 10 25. Into 8 by 25. Ma'am, minus 80 by 25. Ma'am, and it can be simplified minus 2 and 5.
First simplify always. So 1 by x is equal to minus 16 by 5.
Minus 16 by 5.
Now take reciprocals on both the sides. See, 1 minute. If 1 by a is equal to 2 by 5, a is equal to 5 by 2. Take reciprocals on both the sides.
X is equal to minus 5 by 16.
That's all. See, you're writing 1 by x as x. No, you're writing the reciprocal. You're writing 1 by x as x. That means you're writing the reciprocal of 1 by x. So write the reciprocal on when it's an equation, you should do the same action on both the sides. So on one side, you're writing the reciprocal. On the other side, also do the same thing. So 1 by x is its reciprocal x is equal to the reciprocal of minus 16 by 5 is minus 5 by 16. So the value of x is equal to minus 5 by 16. Write down.
Ma'am, finished and wrote a few steps for the next sum. Same.
Akshita, Harini, Srijit, and other boys. Any questions?
Ma'am, almost done. No, ma'am.
Okay. Can we go to the next one?
Yes, ma'am. No. Ma'am, yes, ma'am.
Okay.
Done,
Srijit, okay. Srijit completed? Okay. You can take this y is equal to minus 2 by 3.
Ma'am, y is equal to minus 2 by 3 divided by minus 8.
Yeah. So again, minus 8 by 9 y. They are in multiplication. They are connected with the operation multiplication. So when you take minus 8 by 9 to the other side, it goes for division. So write y is equal to minus 2 by 3 and transpose minus 8 by 9. Minus 8 by 9 will come as minus 8 by 9 only. But for division, minus 8 by 9 will come to the other side as minus 8 by 9. It's a multiplication on the left hand side. So it will come for division to the right hand side. Is this understood, all of you?
Yes, ma'am.
Yes, ma'am.
Okay. Division becomes multiplication and 8 by 9 becomes minus 9 by 8. So now simplify. 3 ones are 3 threes are 2 ones are 2 fours are. So y is equal to minus into minus
3 by
plus.
4. Ma'am, 3 by 4. Yes, ma'am. Yes, ma'am. I got the same answer.
Okay. Minus into minus plus 1 into 3 3, 1 into 4 4. Y is equal to 3 by 4.
Done, ma'am.
Yeah. Okay. Next one. See, you're supposed to take the question from here, children. Don't follow the serial number. Serial number, you continue with, what you have in your book. You're supposed to write this heading, fill in the blanks, write this question, then take the answer. Then there's the next question and then take the answer. Okay. Minus 1 plus, say,
Ma'am,
m.
X, ma'am. Ma'am, or any other variable. Ma'am, can we choose the same variable?
Yeah, you can. You can.
Ma'am, answer is minus 7 by 9. Yes, ma'am.
Okay. So here minus 1 and m, they are connected with the addition symbol. Right? So when it is plus minus, when two things are connected by the plus or minus sign, look at this number. This is minus 1. So it will go to the other side as plus 1. This is nothing but minus 1 plus m is equal to minus 2 by 9. Now minus 1 when it goes to the other side, plus 1. So m is equal to minus 2 by 9 plus 1. This you already know. So m is equal to common denominator 9 minus 2 plus 9. Because this is by 1, right? If some of you might have trouble here while taking the LCM, see, m is equal to minus 2 by 9 plus 1 by 1. So m is equal to, the common denominator is 9 into 1 into 1 into 9 into 9. So minus 2 plus 9. So m is equal to 7 by 9. Correct?
Ma'am, minus 7 by 9. Ma'am, I got 7 by 9. Ma'am, I got 7 by 9. Ma'am, minus 7 by 9, ma'am. 7 by 9.
I got 7 by 9, ma'am.
Ma'am, I worked it when you were in the first time, ma'am. After, when you finished your... Ma'am, me and Anila worked it. Ma'am, in the first time when you were there, I worked it. Oh! Oh, shit.
Okay. Next one. Ready?
Yes, ma'am.
Akshita, any doubts? Are you there, Akshita? Srijit, any questions?
No, ma'am.
Okay, and here Harini and Navneet.
Ma'am, done the whole row, ma'am. Ma'am, done the whole row, ma'am. Yes, ma'am.
Okay. Two by 3 minus x is equal to 1 by 15. So minus x is equal to 1 by 15 plus 2 by 3 on the other side minus 2 by 3 plus 2 by 3 on the other side minus 2 by 3. So minus x is equal to 15 as a common denominator into 1 into 1 into 5 into 5. So it will be 1 minus 10 minus 9 by 15. You can cancel the minus on both the sides. And also 3 3s are 3 5s are. So x is equal to 3 by 5. Am I right?
Yes, ma'am.
The others?
I have a doubt, mom.
Ma'am, I'm doing the next row, ma'am. Last two sums. Going to finish, ma'am.
Oh, I
Yes,
see.
ma'am. Finish.
If you're already ahead, answer my question. Have you finished this? Yes or no?
Ma'am, yes, ma'am.
Updating on your status is only disturbing the others. If
Yes,
this is
ma'am.
my question is this over? Yeah, just say yes.
Excuse
Happy?
me.
Okay, you're ahead. That's good. But let's not disturb the class also. There are others who are still working this, right?
Excuse me, mom.
Yes, Akshita.
Mom, I have a doubt, mom.
Yeah, I've been calling out to you. Where were you?
I went to restroom, mom.
Okay, okay. Sorry, yeah.
It's okay. Mom, why minus x and minus 9 by 15 gets cancelled? Why the minus sign gets cancelled, mom?
Just 1 second, 1 second.
Yes.
Yeah, sorry, and thank you, children. Akshita, yeah, you help me. Yeah, you help me proceed. Yeah, next what? Just see here. You have to transpose. You'll have to transpose 2 by 3, right?
Yes, ma'am.
So don't write that. Write everything else. Minus x is equal to 1 by 15. Now transpose
Okay.
2 by 3. Now transpose 2 by 3.
Okay, ma'am.
See, you should write everything other than what you have to transpose. You'll have to transpose 2 by 3. So don't write that.
Okay, ma'am.
Write the rest of the equation. Minus x is equal to 1 by 15. Now take 2 by 3 to the other side. It will come to the RHS as minus 2 by 3, correct?
Yes, ma'am.
Okay. Now after this LCM, correct?
Yes, ma'am.
Okay. So write minus x as it is equal to LCM is 15 into 1, correct?
Yes, ma'am.
Into 5, correct?
Yes, ma'am.
Because 3 5 are 15, 15 1 are 15. So 1 into 1, 1 minus 10, correct?
Yes, ma'am.
Minus x is equal to 1 minus 10 is minus 9
Okay, ma'am.
by 15. Now minus on either side you can cancel. See, supposing you have minus a is equal to minus 5. You can cancel minus and minus like this.
Okay, ma'am.
So I cancel the minus and minus sign on both the sides.
If both are the same sign, we can cancel it.
Yeah.
Okay, ma'am.
Now 3, simplify. Reduce this fraction. 3 3s are 3 5s are. So x is equal to 3 by 5. Correct?
Yes, ma'am.
Yeah, right now. Okay, done writing? Completed, children? Okay, no response. I'm clearing the screen.
Yes, ma'am.
Okay. Okay, let's answer true or false. Rational numbers are always closed under subtraction. So closed meaning rational number minus rational number is always a rational number. True or false?
True.
Rational numbers are always closed under subtraction. That means you'll have to check if rational number minus rational number is always a rational number. Yes,
Yes,
rational
ma'am.
number
True, ma'am.
minus
True.
rational number is always rational. True.
5 by 2 minus 2 by
Rational number divided by rational number. Rational numbers are rational number. Disable your mind. Rational numbers are closed under addition, subtraction, and multiplication, but not under division. And that too only for that exception. Division by 0 is not defined. Otherwise, rational numbers are closed under division also. Rational numbers are closed under addition, subtraction, and multiplication. Rational numbers are not closed under division if you don't consider division by 0. Then rational numbers are closed under division also. When you divide a rational number by another rational number, the resultant is also a rational number, except when you divide by 0. When you divide by 0, like when you divide 1 by 5, divided by 0, it's not defined. Any rational number divided by 0 is not defined. So in this case, rational number divided by rational number is not a rational number. Other than this, rational numbers are closed under division also. Rational number divided by a rational number is also a rational number. Okay, so this is true. Rational numbers are always closed under division. No, not always closed under division.
False.
1 divided by 0 is 0.
True. And false, ma'am. 1 divided by 0 is not equal.
Subtraction is commutative on rational numbers.
True, ma'am.
Okay, so see here, 7 minus 5, is it the same as 5 minus 7?
No, ma'am. 2 is not equal to minus 2. So false.
So
Yes,
subtraction, see, subtraction is closed on rational numbers. Closure property is true. Commutative is not true. Rational numbers are closed under subtraction because rational number minus rational number is a rational number. That is true. But commutative property is not true. A minus B is not the same as B minus A. False.
Ma'am, last one is true. Minus into minus plus, so 7 by
Last
8
one
is
is
equal to
true,
7 by
ma'am.
8.
Correct. Because minus into minus plus, so plus 7 by 8. True. Correct? Write down.
Done, ma'am, already.
Commutative means, like for the fourth one, it is A minus B, B minus A. It's not the same. A minus B is not the same as B minus A. So it's false. They are closed, but they're not commutative. Rational numbers are closed under subtraction. Rational number minus rational number is a rational number. But subtraction is not commutative. A minus B is not equal to B minus A.
Ma'am, can you go to next one?
Yeah, I'm just waiting for the others to finish. Done, children?
Done, ma'am.
Okay. Yeah. I'll give you a total of 10 minutes or not 10, less than 15 minutes for this. I'll come back in 15 minutes and we'll see the answers. Please work. I'll come in less than 15 minutes. We'll discuss the answers. Okay. We'll see the answers. Stop working. Children, I'm back. Please stop working. Yeah, what's the correct option for the 10th one? What should be added?
Ma'am, 4/15.
4/15, is it?
Yes, ma'am.
Akshita, Srijit.
Yes, ma'am.
Correct option is
4/15.
Okay. Okay. Option C. Here, what should be subtracted?
Minus 17 by 12.
Minus 17 by 12.
Correct. Option C and D. Correct.
Minus 14 by 12. Ma'am,
So the
minus
10th
4/5. Ma'am,
One
4
second.
by 5. Next one.
Please wait for me to ask you.
Yes, ma'am. Okay.
For question number 10, the correct option is C. For question number 11, the correct option is D. Now, I'll tell you what this question means. When the power is -1, that means you will have to write the reciprocal of the rational number inside the bracket. We have to write the reciprocal of the rational number inside the bracket. When the power is -1, it means we have to write the answer is the reciprocal of the rational number in the bracket. So what do we have in the bracket? -5/4. What's the reciprocal of -5/4? -4/5. That's the answer. So the power -1 means write the reciprocal of the rational number inside the bracket.
Correct, ma'am. Yes, ma'am. Minus 4/5, ma'am.
No, boys, I must say that, I don't know if it is one of you or all the three of you, I'm not sure, but to, whoever it applies, it's really bothering me. Don't disturb the class unnecessarily. So when the power is -1, we have to write the reciprocal of the rational number in the bracket. In the bracket, we have -5/4. The reciprocal of -5/4 is -4/5. So the correct option is option B. Next one. Yeah, now I want the answer from you. Which is the correct option? Anybody can answer? Nobody's worked this?
Ma'am, I have worked, ma'am.
Yeah, what's the answer?
Ma'am, 5/6.
5/6, 13th one. So the product of -3/10 and 5/6. So 3 ones are 3 twos are 5 ones are 5 twos are is -1/4. So correct. 5/6 is the correct option. Because one of the numbers is -3/10 and the other number you say is 5/6. Now the product of these two should give you -1/4. And yes, 3 ones are 3 twos are 5 ones are 5 twos are. So -1/4. So option A is the correct option. Option A is the correct option. -5/6 into -3/2. Division becomes multiplication and reciprocal of -2/3 is -3/2. 3 ones are 3 twos are. So minus into minus plus 5 by 4. Got this? Option B is the correct option. Got this?
Yes, ma'am.
Okay.
Yes, ma'am.
Ma'am, can I say the answer for the next one?
Okay, what's the answer?
Ma'am, option C, minus 8 by 15.
Okay. 4 by 3 divided by minus 8 by 15. So this will be 4 by 3 into minus 15 by 8. 4 ones are 2s are 1 and 5. So minus 5 by 2. Correct. Option C is the correct option. This is verification. What I'm doing is verification. You will not be working with these steps. See, now when I think Navneet told me this answer, I just verified 4 by 3 divided by that correct option. Is it giving me minus 5 by 2? This is verification. But you will not be working like this. Your working will be different. 4 by 3, we just did some time back. Divided by x is equal to minus 5 by 2. 4 by 3, division becomes multiplication. Reciprocal of x is 1 by x is equal to minus 5 by 2. 1 by x is equal to minus 5 by 2. 4 by 3 to the other side divided by 4 by 3. So 1 by x is equal to minus 5 by 2 into 3 by 4. Correct?
Yes, ma'am.
Continue here. 1 by x is equal to minus 15 by 8. So taking reciprocals on both the sides, x is equal to minus 8 by 15. So this is how you work to find the correct option. We did one on all the operations, addition, subtraction, multiplication, division. We just did it here in this question. So I'm not actually, like explaining in detail because we just finished. See here, fill in the blanks. Every
Excuse me,
operation.
mom.
1 second. How to handle every operation. See your division, multiplication, addition, subtraction. So I did explain how to handle the operations when we did these 4 questions. Yes, Akshita?
Mom, I wanted the slide, mom. Can you show it for a minute, mom? I take a screenshot.
Which one, ma? This one, huh?
Yes, mom.
Yeah. No, don't take a screenshot. Okay, yeah, okay.
I'm done, mom.
Okay. What's a reciprocal of minus 7 by 9?
Mom, minus 9 by
Minus
7.
9 by 7. B. Option B.
Option B, minus 9 by 7.
Minus 9 by 7. How do you find the rational number between these two numbers?
Ma'am, equivalent fraction. Equivalent method. Equivalent or mean method. Ma'am, we take the LCM of both the denominators. We get LCM is equal to 6. Ma'am, and the number between them and the option is minus 1 by 6. Yes, ma'am. Ma'am, I wrote my own number, ma'am, by mistake. I didn't know that options. But I got minus 4 by 6 and 3 by 6. I got those numbers in the end.
Oh, see, that means, you are not connecting with the question. You have to select the correct option. From the options given, you'll have to choose one. You are trying to insert two rational numbers between the given rationals. That is not the situation here. So you're not supposed to work like that.
Yeah.
So bring the rational numbers minus 2 by 3 and 1 by 2 to denominator 6 because 6 is the LCM of 3 and 2. The denominator is 3 and 2, LCM is 6. So bring minus 2 by 3 to denominator 6. 1 minute. Not getting the eraser, just a minute. Dear children, minus 2 by 3 and 1 by 2. LCM of 3 and 2 is 6. So now minus 2 by 3 into 2 is minus 4 by 6. Or if you want, you can write like this. Minus 2 by 3 is equal to minus 2 by 3 into 2. Minus 1 by 2 is equal to so now it's not possible to insert, no, because minus 3 minus 4. Minus 3 minus 4. Is it possible to insert using these two numbers? I'm not getting any answer. Danvin?
Ma'am,
Yeah. Can you find a rational number between minus 3 by 6 and minus 4 by 6? Yes, there are infinitely many rational numbers between these two numbers. But does minus 1 by 6 lie between these two numbers?
no, ma'am.
Does minus 5 by 6 lie between these two numbers?
Yes. Ma'am, I think answer is minus 1 by 12.
Okay. So how do you do that?
Ma'am, but it is positive 1 by 2. What is negative 1 by 2? That is what I will.
No, what?
No, you wrote as negative 1 by 2.
I'm so sorry.
That's why we are confused.
Oh, sorry. Oh, then.
Yes, ma'am. That's why minus 1 by 6 is the answer. This.
Oh, yeah, okay. Oh, I'm sorry if I confused the class. I didn't notice my mistake. Okay, so it's then minus 4 by 6 and 3 by 6, right? Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. So it's minus, so between minus 4 and 3, minus 4 and 3. So you can write minus 3 by 6, minus 2 by 6, minus 1 by 6, 0 by 6, 1 by 6, 2 by 6. So what is given here? Minus 1 by 6, right? Correct. So minus 1 by 6 is the correct option. See, bring the fractions to the same denominator. After that, look at the numerators. Between minus 4 and 3, see the integers between minus 4 and 3. Between minus 4 and 3, see the integers. Between minus 4 and 3, you have minus 3, minus 2, minus 1, 0, 1, 2. So minus 3 by 6, right? The denominator by 6. Minus 2 by 6, minus 1 by 6, 0 by 6, 1 by 6, 2 by 6. So from these numbers, you in the option, you have minus 1 by 6. So that's the correct option.
Yes, ma'am.
Okay, next one. Yeah, Dhanvin, Anirudh and Navneet have already given you the instructions. Please follow that. Yeah. Next one. You don't have to write this, children. Name the property. Harini. Harani, please name the property.
Commutative property. Commutative property of commutative property of multiplication of rational numbers.
Very good, very good. Commutative property of multiplication of rational numbers. Very good. Next one, Akshita.
Ma'am,
Property.
ma'am, multiplicative identity, ma'am.
Multiplicative identity of rational numbers. Very good. Next one, Srijit.
Associative property of multiplication.
Very good. Associative property of multiplication of rational numbers. Very good. Srijit, next one also.
Multiplicative identity.
Multiplicative, not identity.
Multiplicative inverse.
No, no. You can just say something else. No, no, not identity, not inverse. You can just say, because for this, there is no specific property kind of, but you can just express it. So the property of zero. So yeah, so the product of a rational number and zero is zero. The product of a rational number and zero is zero. That's the property of zero with regard to multiplication of rational numbers. You should just write property of zero. Property of zero. The product of a rational number and zero is zero.
Okay.
Yeah, anyone can explain, anyone can say the property for the last one?
Can I say?
Yes.
Associative property of multiplication of
Ma'am, distributive property of addition of rational numbers, ma'am.
You're right, but not completely right. You are right. But you missed one important term. Distributive property of
Addition of
multiplication.
Multiplication.
Over addition of rational numbers, ma'am.
Over addition. Very good. Was that Srijit?
Yes, ma'am.
Very good. Yes. Correct. Akshita, you were also right. So it's the distributive property of multiplication over addition. It's a distributive property of multiplication over addition. A into B plus C is equal to A into B plus A into C. Very good. For these MCQs, I'll share the detailed steps. I'll work and share the detailed steps. Now we just discuss the options because similar questions we have answered earlier. So I did not work the steps for you, but I'll share the steps so you can check it later. Now I just told you the options. Yeah, we'll wind up today's session with this one. We'll work this and wind up the session for today. Divide the product of 5 by 9 and minus 6 by 5 by their difference. Yeah, try this. I'll just come back. All right. So divide the product of 5 by 9 and minus 6 by 5 by their difference. So we first have to find the product of 5 by 9 and minus 6 by 5. So how do you find the product? You have to multiply 5 by 9 into minus 6 by 5. So 5 cancels, 3 2s are, 3 3s are. So it's minus 2 by 3. Difference of 5 by 9 and minus 6 by 5 is equal to 5 by 9 is one number. Somebody's mic is enabled. Please disable your mic. 5 by 9 is one number. Minus 6 by 5 is the other number. We need to find the difference of these two. So you should put a minus sign in the middle. 5 by 9 is one rational number. Minus 6 by 5 is another rational number. Find the difference. So put a minus sign in the middle. See here, 5 by 9, one number. Minus 6 by 5, the other number. Find the difference. So it will be 5 by 9, minus into minus plus 6 by 5. Don't get confused that you're adding. Minus into minus is plus. We put a minus sign for difference. Now minus into minus is plus. 45 is the LCM. Into 1 into 1. Into 9 into 9. So it will be 5 ones are 5 plus 6 nines are 54. Which is 59 by 45. This is the difference. So what is given? Divide the product. You should divide the product by the difference. So you should divide 1 by 2. This answer. This is one answer. This is the other answer. You must divide 1 by 2. See, it's very clear. Divide the product by the difference. Divide the product by the difference. Yes, somebody said something.
Ma'am, can I say the answer?
Srijata?
Yes, ma'am.
Yeah. So tell me what will be the next step.
Ma'am, we have to divide this difference and the
Product and the difference.
yes, ma'am. Product and the difference.
Yeah.
So the answer is minus 90 by 237, ma'am.
Okay, so it will be minus 2 by 3 divided by 59 by 49, 59 by 45. Correct. So this will be minus 2 by 3
Minus
into
2 by 3 into 45 by 59.
Very good. So 3 ones are 3 15 times. Did you simplify?
Yes, ma'am.
Okay. So minus 30 by 59. Correct?
Yes, ma'am.
Very good. So first you should find the product. Then you must find the difference. Then you should divide this answer by this answer. So minus 2 by 3 divided by 59 by 40, 59 by 45. So division becomes multiplication, then reciprocal 45 by 59. Cancel. And the answer is minus 30 because 2 into 15 is 30. So minus 30 by 59. All right.
Yes, ma'am.
Akshita,
Yes, ma'am.
understand?
Yes, ma'am.
Yes, ma'am.
Yeah, please write down. Harini?
Yes, ma'am. Understood, ma'am.
Okay, please complete. Your father's come to take you. Finish working this and then you can leave.
Yes.
Finish this one, all of you?
Yes,
Yes,
ma'am.
ma'am.
Okay. All right. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am. Thank you, ma'am.
Good night,
Good
ma'am.
night,
Thank you,
Thank
children.
you, ma'am.
Thank you, children. Thank you.